which is 8080. So this is going to point to the Evently API instance running inside of the Docker network. And now that I have my cluster, I can define my API routes. We need to give our route a name, the same as we did with a cluster. And then I need to specify the cluster ID, which this route is going to reference. And this is going to be my Evently cluster. Then what I can do is configure the authorization policy. And this is going to help me set up authentication for this route. And I can say that the policy name is going to be default, and this just requires all incoming requests to be authenticated. Then I need to set up how I'm going to match this route. And you can do that by specifying the path. And I'm going to use a wildcard catch-all argument. And this is going to allow me to match any incoming requests into the reverse proxy. Then another thing you can configure is how you want to transform this request before sending it to the downstream service. And you specify this inside of the transforms section in plural, and this accepts an array of objects. And I can specify what is the pattern that I want to apply to the downstream service. So I'm also going to specify the same wildcard because I just want to route whatever I caught on the reverse proxy to the downstream service. And this is our basic reverse proxy setup that is just going to proxy all incoming requests to the Evently API service. Now, one thing you might wonder is what will happen to routes where I don't need authentication if I specify the authorization policy as default. One example of this is the user's register route, which allows anonymous access, and in this case, our route would not be reachable. So what we have to do is to specify another route that's going to apply a different authorization policy for this specific endpoint. Our routes need to have unique names, so I'm going to update them to be Evently Route 1 and Evently Route 2, and they will be using the same cluster. So both of these routes will be sent to the Evently API running inside of the Docker network. Except here, I'm going to specify that the authorization policy is anonymous, and then the path that I will try to match is users/register. I can omit the transform section if I don't want to transform this request at all. And this is just going to route incoming requests to the user's register endpoint on the reverse proxy to the respective endpoint on the Evently API. And now we should be ready to start the application and test out the reverse proxy. With the application running in the background, we can open up Docker Desktop and you can see our gateway container has started and it's exposed on the port 3000. If I go into the container instance, you can see some initial logs, and the most important one is this, where it says that it's loading proxy data from application settings. If I go over to Postman, I should be able to send a post request to the user's register endpoint on the reverse proxy and expect it to hit the Evently API, register the user, and give us back the response. I'm also noting that I updated the API URL variable, which I set up in my development environment to point to HTTP localhost 3000, which is where we expose the reverse proxy. If you are using the same Postman collection as I am, you should be able to easily do this. Now let's go ahead and send this request. And after a few moments, we get back a 200 OK response, and it looks like our reverse proxy is working. Let's head over into Jaeger and take a look at some distributed traces. On the Jaeger user interface, I'm going to look for the Evently gateway service, and I have just one trace here, which is the request to the user's register endpoint. Here we can also note that the anonymous policy on our reverse proxy is working as expected, although we are yet to confirm that until we try to access a protected endpoint. But let's take a look at this trace. So we have a request to the post user's register endpoint on the Evently gateway service, which is our reverse proxy. Then you can see that the proxy is forwarding this request to the Evently cluster, which is the one destination route that we have. It's going to send the same post request, and the URL is going to be the internal port of the Evently API service, and it's going to send the request to the same route, which is users register. Then we have another span, and this time in the Evently API service, and this is the incoming request into our API instance. You can see this is being handled by the register user command. This is going to send a post request to Keycloak to obtain an access token using the client credentials flow, and then it's going to send another post request to Keycloak, and this time accessing the admin API to attempt to register the user. You can see that this succeeds. Then we have another trace where we are opening a database connection, and lastly we have another span where we are inserting our domain event into the Outbox messages table, adding the user to the users table, which is the statement here, and we're also adding the user to the respective role. So you can see how distributed tracing allows us to track the complete flow of an API request from the moment it hits the API gateway, and then it gets proxied to the respective backend service until the request hits the database and persists the required data. Now let's go back into Postman and just confirm that authentication is working as expected. I'm going to send a GET request to the user's profile endpoint, and you can see that we get back a 401 unauthorized response because we aren't specifying a JSON web token. Now I'm going to get an access token instance for a user that I already have registered with Keycloak, and now if we specify the access token as a bearer token value and send it inside of this request, you can see that the request succeeds. We get back a 200 OK response as well as the user's information. Let's go back into Jaeger and examine the two requests that we sent to this endpoint. You can see that we have two traces here, which represent the two requests that I sent to my proxy. The first request doesn't contain an access token, so we immediately get back a 401 unauthorized response, but let's take a look at the second trace, which contains quite a few spans. And here I want to show you something interesting. We have our incoming request, which matches the catch-all route. Now, if you take a look at this span here, you will see that this is a request to our Keycloak service. So what we can figure out from this is that authentication on the reverse proxy is working as expected. You will also see another request here to fetch the certificates from Keycloak, and after authentication succeeds, only then are we going to forward this request to the Evently API service. And then on the Evently API, you're going to see the same request to Keycloak because this service also has to authenticate the incoming request, regardless of the fact that the user was authenticated with Keycloak on the proxy. And this is both good and bad. It's bad because we have to talk to the identity provider twice, but it's also good because we are going to need the JSON web token on the Evently API anyway to extract the incoming claims from this token. So in that regard, the implementation that we have in place makes sense. Now let's take this trace identifier and head over into Seek. And if I filter the logs based on this trace identifier value, we can see the logs for our distributed request. Here is the log from our proxy, which is executing from the YARP source context, and then is proxying this request to the Evently API service. And here you can see some logs from Evently API, and eventually we're going to transition from the Evently API application into the Evently gateway, and finally return the response to the API caller. So this is how we can use the information from our distributed traces and take the trace identifier in order to track a distributed API request through all of the applications that it's flowing through before we get an API response. With the introduction of YARP as a reverse proxy inside of our system, we are ready to move from a modular monolith architecture into a microservices architecture. And in the next lesson, we will be extracting one of the modules from the modular monolith into a dedicated service.